Hello, thanks for joining our YouTube channel. This morning we're going to talk about the root cause of dementia. What is actually driving the dementia process and what we can do to help flatten that process from turning into a very difficult problem in your 70s and 80s. I'm Patrick Smith and I'm the Chief Executive Officer of Brain Love Health. And this is part 2 of a 2-part series that we initiated last week. And I'm going to review for you a little bit about part 1, and then I want to dig into what part 2 is all about, because this is the most important part of the topic. This is the part of the topic where you get to learn how the process begins and what you can do to change the trajectory in your later years. It's an exciting topic. It's something that I've been studying now for over 20 years. I collaborate with researchers and scientists from around the world. This is real science. This is the real answer that I think can help with the problems of dementia. So let's talk about part 1. In part 1, I discussed the fact that women outnumber men in dementia process 2 to 1. And that's when I say the dementia process, there's multiple forms of dementia, and I reviewed those in part 1. There's frontal lobe dementia, there's Lewy body dementia, there's Parkinson's disease, there's cerebral vascular dementia, and then there's Alzheimer's disease. Alzheimer's disease is the most prevalent form of the disease, and it is typically the dementia that you get when you're older, in your 70s and 80s. But I want to emphasize that all those forms of dementia begin way before the symptoms occur. The causes start many, many years before you start to see the problems arise. So that's one part of the equation. The second part of the equation is multiple factors come into play when you're talking about dementia. It's not one specific target. It's not one thing that is driving the dementia process. It's a multitude of issues that make the dementia process turn into what we know as Alzheimer's disease. What are those factors? Well, we know that there's neuronal cell division, and I'll talk about that a little bit in this section. But neuronal cell division is not normal. It's not something that we want to see. We also see inflammation. We also see oxidative stress. We also see the proliferation of beta amyloid plaques in the brain, and many people equate the disease with that specific target. That's not the problem. That's part of the problem. We also see neurofibrillary tangles, which basically clog up the axon and the dendrites of the neuron, which allow you to send signals to the next neuron. That's a problem, but it's not the problem. All those things come into play, and they interact with each other, which drives the process to occur. And it takes place over a 20-year period. It just doesn't show up one day on your 65th birthday or your 75th birthday. It shows up many years, and then it progresses like a forest fire. It starts out smoking, and then it keeps building, till we see the raging inferno in your brain, which we know as dementia and Alzheimer's disease. So let me talk now a little bit about the root cause, where I see the beginning of this problem occurring. As I mentioned earlier, women outnumber men 2 to 1 in the disease. And for years and years and years, scientists and researchers have been asking this question, what is why would that be occurring? Now, for many years, people say, oh, well, women live longer. That's why they get dementia more. That's not it at all. Because there are studies and research that suggest that if you take age-matched controls at 75 years old and look at men and look at women, women have it twice as much. So it's got nothing to do with the fact that women live longer. What it has to do with is that women's hormones are different than men's hormones. Now let's unpack that process a little bit. We all know women and men are different. But we also know that women and men have different hormonal cycles throughout their life. We know that women go through a very abrupt menopausal process, and typically it takes maybe 5, 6, 7 years max. And the average age of female menopause is around 50, 51. Men go through a much more slow process of hormonal degradation. That is, their testosterone starts deteriorating in their 30s and 40s and probably goes down by 2 to 6% every year after that until they get older. Whereas in women, things work fine in their 30s and their 40s, and then all of a sudden they hit perimenopause. And then the estrogen and all the other hormones that interact there start to get complicated and not functioning the way they should. And by the time you're 55, typically most women are through menopause, and there's very, very, very little estrogen being produced. Now, what the heck does estrogen and testosterone have to do with dementia? I'd like to step back a little bit and refer to the chart over my shoulder here, because this is the root problem that needs to be addressed, and it hasn't been addressed. We listen to people talk about estrogen. We listen to people talk about testosterone. That plays a part in the process, but it's not the root cause. So let's talk about this chart. You'll notice in the back of me, I have this chart that's titled the HPG axis. The hypopituitary gonadal axis. That's what that HPG axis stands for. Hypothalamic pituitary gonadal axis. And it is the hormonal system that regulates your hormones throughout your life. It regulates your hormones when you're a fetus, when you're a child, when you're an adolescent, when you're in your reproductive years, and then it stops functioning the way it did throughout your lifetime and becomes what we call dysregulated. When that process occurs, you start to see the changes that you start to experience in menopause and andropause, because your hormones are no longer interacting the way they're supposed to. Now, how does the HPG axis work? It starts with the brain, the hypothalamus, the hypothalamic pituitary gonadal axis. It starts with the brain, and the brain secretes a hormone called gonadotropin releasing hormone. Well, it stimulates that to get the pituitary to produce FSH and LH. What are those? Luteinizing hormone and follicle stimulating hormone. It starts in the brain, it goes to pituitary, a stimulus of GnRH, then the pituitary stimulates LH and FSH. That's the key point that you have to take away here. It's that process that then stimulates the ovaries and the testicles to produce estrogen and progesterone, and in the testicles, testosterone. Estrogen and progesterone and estrogen in the ovaries, and testosterone in the testicles. Now, this process interacts all the time from which you become mature from a reproductive standpoint in your adolescence, 12, 13 years old. So that process continually works. The hypothalamus stimulates the pituitary stimulates the production of LH and FSH. LH and FSH then stimulate the production of estrogen and progesterone, and in men it stimulates the production of testosterone in their testicles. Once that process occurs, there then is a signal back to the hypothalamus in the brain that says everything is working as it should. Now, we all know when women go through their regulatory cycle every month, their hormones go up, their hormones go down. That's an interaction between the brain, the LH, the FSH, and the ovaries. When the ovaries produce the estrogen and the progesterone, it sends a signal back to the brain and says everything is working. And that system regulates month by month by month for a period of probably 30 years, maybe longer. In men, it's the same thing, but it doesn't cycle like it does in women. So here's what you have to understand. At the point in which the ovaries cannot produce estrogen and progesterone, that signal back to the brain doesn't occur. So the feedback of the HPG axis is broken. So what happens when it's broken? A major function of all organisms is reproduction. A major function of what we do as an organism, whether it be a human or an animal or a fish, their primary function is to reproduce. So this system works very similar in all species. But what happens when we reach middle age? We know what happens. Women are unable to keep producing their eggs. And when they can't keep producing their eggs, because there's a finite number that you have in your ovaries, and when you can't produce more eggs, this feedback loop gets broken. Now, what happens to the body when it happens? We all know what happens in midlife. We know you start to put on some weight. We know you get moody. We know you get hot flashes. We know you have trouble sleeping. These are all symptoms of a dysregulation in the HPG axis. But there's more that occurs here. When the brain does not get the signal from the ovaries and the testicles, it starts producing more GnRH. It starts producing more because it wants to maintain reproductive function. And when it starts to produce more GnRH, it starts to produce more LH and FSH. And when that occurs, it still doesn't get what it wants. It can produce all this it wants, but the ovaries aren't going to give it the estrogen it needs and the progesterone it needs because it can't do it any longer. You've reached a point where you're no longer reproductively functioning. So it's a dysregulation. It's a dysregulation. Now let's talk about what people have been discussing relative to menopause, dementia, estrogen, and all those types of things. So much focus has been focused on the fact that you're now not producing enough estrogen. That's the focus of most of the research relative to hormones as it relates to dementia. I propose, and our research for years and years has shown that it may not just be the estrogen, but the major culprit is luteinizing hormone. Luteinizing hormone is the problem here, and it needs to be studied more, and we have been studying it. And let me tell you a little bit about luteinizing hormone. Years ago, when I started to do research on this topic, we tried to understand what was it that was causing neurons to try to divide. Now, you need to understand neurons aren't formed. Their function is not to divide like most other cells in the body. Neurons are what we call terminally differentiated cells. That means terminally differentiated, it means they're not supposed to divide. Now, why is that? Think of your brain, and it's full of electrical conductions, and your neurons are basically the circuitry of those conductions. Evolutionary speaking, would make no sense for the neurons to divide because it would break the circuits up. I hope that is super clear, because if the circuits of the neurons start to get broken, obviously all the memories and the storage and all the data that's stuck in your brain starts to get unable to get processed. So neurons are evolutionarily designed not to divide. Now, what happens when they divide? When a neuron starts to divide or go into the division process, that is a separation of one cell into two. When that happens, in neurons, they die because they can't complete the cell division. Now, why is that? Neurons do not have all the components that a lot of other cells have. More specifically, neurons miss a cellular component called centrioles. Centrioles are what allow a cell to complete a cell division. So when a new neuron starts to divide, it dies. Now, why is this important? Our research has found that LH is causing neurons to divide. Now, there's many receptors in the hypothalamus, in the hippocampus, that basically attract luteinizing hormone. So what starts to occur as you reach midlife is you get this significant increase in luteinizing hormone, and luteinizing hormone happens to be that hormone that drives cellular division, growth, and development throughout your life. It's very advantageous for you when you're in utero as a fetus, as a child, as an adolescent. You're growing, you're getting bigger, you're becoming reproductively viable. LH plays a significant role in that process. But when you reach the point where you're no longer reproductively viable, the very hormone that helped you grow and develop is now the same hormone that's causing problems and driving a lot of the symptoms that are occurring as you reach menopause. Well, what does that mean? The luteinizing hormone, when it doesn't get the feedback to the brain, keeps going up, estrogen keeps going down, and you get a dysfunction in the HPG axis, which is driving neurons to divide. Now, why is that a problem? Because it's the root cause of what's driving the downward multifactorial issues that occur in dementia. The neurons start to divide. Now, does anyone see that as a bad thing? And when your neurons start to divide, they die. So now you have dead tissue up there. You have broken circuitry up there. You have things occurring there that's not supposed to occur. So once you start to get some neuronal death, you start to see inflammation. Inflammation, as you know, accumulates around all diseased tissue. It's a major problem of chronic disease, inflammation. You then start to see oxidative stress, which is a renegade free radicals that can't bond the way they're supposed to, which causes all kinds of disruptions, not just in your brain, but in your whole body. You then start to see the proliferation of beta amyloid plaques. Now, I believe that's the role that beta amyloid plays. It's an immunological response to the neuronal death, inflammation, and oxidative stress that occurs. So beta amyloid starts to accumulate. We all know beta amyloid plaques clog up the brain. It prevents it from being able to send the signals it can, even in the healthy cells. You also get neurofibrillary tangles, which are little proteins that break off within the axon and the dendrites of the neuron that then prevent the neuron from sending an electrical signal down its extensions. So those are the things that occur. But the root cause is a dysfunction in the HPG axis. And it's not just the HPG axis dysfunction that's causing dementia and other problems of aging. It's causing havoc in all areas of your body. It's leading to things that make you age faster. Now, with this in mind, I realize that many of the things I'm talking about are on the leading edge of dementia research. I realize that this topic is complex. And I realize that most people can't follow the science from this point to that point and this point and understand all the intricacies of the endocrine system. You've heard us talk in other forums that dementia does not start in the brain. That's why I say that. Dementia does not start in the brain. It starts in the dysfunction of the hormonal process in midlife. And it affects women twice as much. And it affects men also, but at a lesser degree. Now, there's two other points I'd like to leave you with here. If, in fact, the HPG axis is the root cause of what's driving the dementia process, I want you to consider these two facts. It is well known in the scientific literature that women that have undergone a hysterectomy have a significant increase in dementia as they age. Women that have gone through a hysterectomy, women that have gone through a oophorectomy, unilateral or bilateral, which is one ovary or two ovaries. So if you've had a hysterectomy and you've had your ovaries removed, guess what? That's the point in which the HPG axis becomes dysregulated. So it makes perfect sense that women that have had those surgical procedures would in fact have more dementia than women that just go through menopause naturally. Now, there's some other issues I'd like you to consider. Women that go through menopause early that's when the process starts. Women that go through menopause some go through it earliest in their late 30s, that begins the 20-year process leading to the symptoms we know as dementia. So the length of your reproductive years has an impact. If you go through menopause at 55, that's a blessing for you. That means the process doesn't start till later. If you go through menopause at 38, that's when the clock starts, basically towards the downward progression. If you've had a hysterectomy, that has an impact. The younger your hysterectomy was, has a greater impact. Those things make a big difference. And what's the root cause here? The thing that's driving the process is a dysregulation of the HPG axis. We can talk about treating all these other symptoms all day long. We can talk about targeting beta amyloid plaques. We can talk about targeting neurofibrillary tangles. We can talk about all those things. But you've got to address the issue from the root. The root is this, the dysregulation of the HPG axis. Now the good news is, that's what Brain Love Health has been focused on for the last 20 plus years. We're focusing on ways to look for treatments, modalities that will balance out the hormonal changes and prevent the process from occurring. Now, what does that mean? We target the lowering of the LH, so it's not spiking that's driving the neurons to divide the way I described. It's not going to eliminate the problem, but it will slow it down. We fight inflammation with our approach. We fight oxidative stress. All these things will slow the process down and keep your brain healthier longer. It doesn't mean it's never going to have dementia. It doesn't mean that forever that you're going to be cured. There's no cure. There never will be a cure because all the drugs they're testing are focused on one of the symptoms that I described, except the neuronal cell division. They're looking at oxidative stress. They're looking at inflammation. They're primarily looking at beta amyloid plaques. I want to say this emphatically. I said it back in 2005 in print. It is not the beta amyloid plaques that are driving the dementia and Alzheimer's process. It's part of the disease, but it's not the root cause. And we've seen through research over the years that you can eliminate the beta amyloid plaque, but you get no clinical benefit. You get no clinical benefit other than your brain has no beta amyloid plaque, but it doesn't help with your thinking. It doesn't help with your memory. We've got to get ourselves away from that. We need to get back to the traditions of Hippocrates that says food can be medicine. That's Brain Love Health's approach. Food is medicine. We want to treat your problem before the problem becomes a disease and slow down the process of middle age and aging process in general. Now, many of the things that will be good for your brain will also be good for your heart, will be good for your overall health. So I would say, and I'll conclude with that as the end of part 2, refer back to part 1 if you want to get an in-depth understanding of the multiple factors that occur in the multiple dementias that occur. And part 2 is designed to get you to understand the root cause is the hormonal changes that occur in midlife. And we as a company are focused on ways to treat and help you. I want to thank you for joining us today. Again, this is Patrick Smith, the Chief Executive Officer of Brain Love Health. You can find us on Facebook. You can find us on Instagram. And our website is brainlovehealth.com. And we talk about this every day. We post things to help you. We don't just talk about the scientific background behind this. We talk about ways in which we can help you. I beg you to look into our work and find ways in which you can keep your brain healthy as you age. Thank you very much.